Record.
Okay, so we're going to continue talking about volume with other cross sections. So these are not axis of revolution. So you don't have circular cross sections. These are like squares, right triangles, so on. So number 2 says, find the volume of the solid whose base is the region bounded by the lines x plus 4, y equals 4, x equals 0, and y equals 0. And the cross sections taken are perpendicular to the x, or taken perpendicular to the x-axis are semicircles. So let's see what we're talking about here. Okay, so if I have this equation, let's solve for y. So I'd subtract my x over, so I get negative x plus 4. And then I divide by 4. So I get negative 1/4 x plus 1. Okay, so that's that equation. Okay, your slope is negative 1/4, so go down 1, right 4. Okay, the cross sections are perpendicular to the x-axis and they're semicircles. So that means you have a semicircle coming up here, 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 here. So it's making like half of a cone. Do you guys see it? Okay, so in class we just did those semicircle squares. You just made your little pictures, or you made your little manila folder graphs. If they're semicircles, that is pretty nice because it's half of the axis of revolution. So you actually could do this problem like a solid revolution. You could do that, but then you could cut it in half. So you could always do it that way. But let's go ahead and talk about how we do it with this other method. Okay, so we know that the volume is going to be integrating all of your areas from x equals 0 to 4. In my cross-section areas, these are semicircles. Okay, so that means I'm going to have 1/2 pi r squared. Okay, and that's why it works out to be half of a solid of revolution, because the 1/2 part. Okay, so we need to talk about what the radius of each circle is. So the diameter is easy to find. You guys see the diameter of each one? So as I move along my x-axis, there's my diameter. So what's your diameter?
The y equals divided by 2.
Yeah. So your diameter is negative 1/2 or negative 1/4 x plus 1. So that means my radius, like George was saying, is just divided all by 2. So it's negative 1/8 x plus 1/2. Make sense? All right. And the reason that x is in there is it's because you're moving along the x-axis, so it's changing. So for the first part, your diameter was plug in 0, you get 1, so your radius was 1/2. And at the very end, your radius is 0. All right, so plug that in. So I have going from 0 to 4 of negative 1/8 x plus 1/2 dx. Okay.
Yeah, do you have to multiply
Oh,
by
yep,
5?
pi r squared, thank you. Forgetting all my squared.
Is that both things?
Pi r squared, right. All right, so we get, yeah, so who did that? Molly said it?
Team effort.
I said the pi or square instead of pi.
Okay. So I'm just going to pull the pi out to the outside. You can FOIL this out off to the side. So if I have a negative 1/8 x plus 1/2, and I'm squaring it, you can FOIL it out. So 1/64 x squared. Your outer and inner are both negative 1/16.
The 1/2 pi?
We already did that with the radius, I guess.
No, because we did that to find radius.
Oh,
and then
man.
we need to multiply that up.
I'm messing
George
up.
did that. No,
Okay.
no, you got that.
All right, so pi over 2
See,
is on the
George
outside.
and Katie. Alright.
Are we good now?
We're golden.
Okay, so negative 1/16, so negative 1/8 x, negative 1/16 plus negative 1/16 is 1/8. All right, plus 1/4. So that's what we're integrating.
Then you shouldn't. No.
Okay, we're going to save some time. I'll let you guys do it on the calculator. You could have done it from the squared part too. I got pi over 6. Do you guys get that? Okay, so pi over 6 is your answer. All right, so you're just finding the area of the cross-section, and it's like you're finding the sum of all those areas. That's what the integration sign means, the sum of all those areas, right? Okay. The dx matters, especially when you get to multivariable calculus, because it's telling you what variable to use. So you could have, like later on, you could have like equations that have, oops.
Like if you wrote, so on the last step, there's not a dx. If you wrote that, would they give you a point off, or they just not really?
I don't know if they count you a point off, but it annoys me when people don't, so it probably annoys them when people don't too. So I would probably do it. Like you might have something like this later in multivariable calculus where you have x's and y's and you have to integrate with respect to x. So in that you would just treat y's like numbers. So that's why it's important later on. Okay, next up. Okay, so it says the Pyramid Arena in Memphis has a square base of length approximately 600 feet and height of approximately 320 feet. So this is 600, and your height straight up from the center is 320. Okay, find the volume of the pyramid with these measurements. So it says, hint, orient your pyramid sideways so that the point is along the x-axis. You'll need to find an equation of a line. Okay, so here's what we're going to do. It's kind of confusing the way I say that, but well, let me just draw the whole axis. Okay, so we're going to have square cross sections, and here's like the side. I don't know the best way to. Those of you that aren't very good at art, this is going to be hard. So it's like that. You see it? That's behind. No, it's just on the XY axis.
Nice try.
Yeah, it is a 3D figure, but yep. So here's let me draw on your 320. So this is 320 from the center to the top, and then your base. So that's along. I'll draw that in blue. That's here. So each side is 600. So it's a square base. You see how I wanted that oriented? In the future, I'll have to just put this in your notes for you. That'd be nice. Alright, so Nick says his looks like a pirate ship. Alright. So we have squares, and you're trying to find the length of each square. Like, do you see this is a square here? And so we have all these square cross sections. Okay, so it helps if we find the equation of this line here. Do you see it? I know it's a big mess right now. So we need to find the equation of this green line. Okay, so that line right here, it has 2 points that are connecting it. Do you see the point at the top? That point is 0, 300. Do you see why it's 300? It's half of the 600, right? This point down here is 320, 0. Makes sense? So my equation, your slope is 300 minus 0 over 0 minus 320. So 300 over negative 320. So reduce that. Negative 15/16. Good. So it's y equals negative 15/16 x plus 300. The y-intercept was 300. 0, 300. Okay. So our area of our cross sections, since they're squares, it's going to be the length of the side squared. So now let's think about it. What we just found is telling us from the axis straight up. That's that length. So what do I need to do to find the whole length of the side of the square? Yep, double it. So my area of my cross section is going to be 2 times negative 15 over 16x plus 300.
16.
Dang. And then square. Yeah.
2.
Okay, so multiply in square. So my volume is going to be 0 to my x value is 320 of that area.
Why would you multiply times 5? You would.
Squared dx. So the question is, why don't we multiply by pi on this one? It's not a circle. So the last one was a semicircle, right? That's why we had a pi in there. This cross-sectional area is just a square, so we just use side squared. All right, so someone find that for me.
Shouldn't 2 be within the brackets?
Yeah, you can put like brackets there if you want, or you can pull it out to the outside. It doesn't matter.
But does it need to be
Shouldn't
squared?
2 need to be squared.
Ah, you're right. Thank you.
Wait.
Hard to
Okay.
keep you up on that?
I know, I haven't recovered from Monday, huh? No, I was just up like late grading. Did you guys get an answer? I got 9600000. Did you guys get that? So 9,600,000.
Wait, so you can
That's a
actually
big
use
scary
this
line.
Nope. You didn't get it?
use this in your life.
Okay, that's in cubic feet.
Yeah.
Okay, so any questions on that? That was the last example. Or is there one more? That's the last one.
Yeah.
That was interesting. So we really know how to do that. It's like